Let's look at example 10.7 out of the Yates book. If you have the second edition book, it's on page 551. And it's about determining the sample size. First of all, as you recall, the formula for a confidence interval is x bar plus or minus z star times the standard error of the estimate, or z star times sigma over square root of n. This stuff on the end is called m, the margin of error. So sometimes the formula is written x bar plus or minus m. On example 10.7, it says that we want to be able to estimate the day's production within plus or minus 5 millivolts with 95% confidence. And we need to know what size sample should we take. Well, first of all, from the normal table, we know that 95% confidence corresponds with a z star of 1.96. 1.96 is going to be my z star for a 95% confidence interval. We also know from a previous problem that sigma is 43. The standard deviation of the population is 43. Now we want the margin of error to be no more than 5. Sometimes, for example, in the book, it's worked out like this. What I found to be easier is simply to work it out like this, and then remember that we need to bump up the sample size a little bit at the end to make sure that it falls at or below the 5 mark. The margin of error is z star times sigma over the square root of n, and that needs to be no more than 5. Now I plug in the numbers. Z star is 1.96. Sigma is 43. I don't know what n is, so that stays the square root of n, and of course the 5 stays the same. There's a lot of ways to work this problem out. You need to figure out the one that works the best for you. One way is, since the left side has a 1.96 and a 43 in the numerator, is to move those things to the other side and then flip it over. Some people prefer to multiply both sides by the square root of n and then divide both sides by 5. That's the method I'll do first. So I'm going to multiply both sides by the square root of n. So now on the left side, so this left side, the square roots of n cancel out, and I get 84.28 equals 5 times the square root of n. And then I'm going to divide both sides by 5 to give me the square root of n is 16.856. And now when I square both sides, I get n is 284.12. And here's where the rub comes, because we know that n can't be a decimal. It's a sample size. It's got to be an integer value. And since I set my original formula equal to 5, I now need to bump up that 284.12 to 285. If I just simply rounded it to 284, that wouldn't quite get me under the threshold of 5 that the problem originally asked for. So 285 samples must be taken to meet this requirement from the problem.